Hello friends, in this video, you will learn scanning beyond IDS and Firewall. We actually made a lecture on IDS and Firewall in Network Security section, so check that section. As a professional ethical hacker or a pen tester, the next step after discovering the operating system of the target IP addresses is to perform network scanning without being detected by the network security parameters such as firewall and intrusion detection system. Firewalls and intrusion detection systems are efficient security mechanisms. Intrusion detection system is a set of tools or systems that monitors and analyzes the network traffic for any suspicious activities and issues alerts when any such activity is observed. Similarly, a firewall is a network security framework that manages the outbound and inbound network traffic by permitting or blocking the packets based on the set of security rules. Firewalls and IDs can prevent the malicious packets from entering a network. An attacker can send manipulated packets to the target such that it can evade the IDs or firewall. There are several such evasion techniques. There is no magic bullet for detecting and bypassing the firewalls or ID systems. All it requires are skills and experience. The first technique we have is packet fragmentation. As the name itself tells, a packet fragmentation is the method where an attacker splits the probe packets into several smaller fragments before sending them to the target network. As soon as the packets reach the target system, the IDS or firewall enqueue them and process each of them one by one. However, being too many packets because of the fragmentation requires greater CPU and network resource consumption. Let me tell you that most of the intrusion detection systems are configured to skip the fragmented packets during the scanning. Therefore, an attacker may use various tools, such as a NAP or frag for splitting the probing packets into smaller packets that can be easily evaded through the port scanning techniques employed by IDS. Once these fragments reach their destination, they are reassembled to form a single packet. Although the SYN or FIN scanning using IP fragments is not a new scanning method, but a modification of previous methods. The TCP header splits into several packets to evade the packet filter, which was our ultimate goal. For a transmission, every TCP header should have the source and the destination port for the initial packet. The initialized flags in the next packet allow the remote host to reassemble the packet when received via an Internet Protocol module that detects. We have second technique, which is source routing. An IP datagram contains several fields, which also include the source routing information and a list of IP addresses through which the packet will travel to reach its destination. If you don't know this already, let me tell you when the packets travel through the different nodes in the network. Each router examines the destination IP address associated with it and chooses the next hop to direct the packet to its destination. Now comes the question, how can this help in firewall or IDS evasion? When an attacker sends the maliciously crafted packets to a target, these packets usually hop through various routers and gateways to reach their destination. However, in some cases, the path also includes the configured firewalls and IDS to block such packets. Thus, to avoid them, attackers strict the routing mechanism in such a way that the packet can reach the destination via some other route such that there is no firewall or intrusion detection system in the path, therefore successfully evades the firewalls and intrusion detection system. The third technique is source port manipulation. Source port manipulation is a technique used for bypassing the firewalls and intrusion detection system, where the actual port numbers are manipulated with common port numbers for evading the intrusion detection system and firewall rules. This is basically masquerading the port that is blocked in configuration rules of intrusion detection system or firewall by the port that is allowed by the framework. That is why it is advised not to trust the source port numbers blindly, to avoid security misconfiguration. Usually, the commonly used ports such as HTTP, DNS, or FTP are allowed for incoming traffic. Let's go to Kali Linux and see how to perform source port manipulation. Open Terminal. We are using Nmap tools. The -G or -- source port option is used to perform the source port manipulation. It will take some time, wait for it. I'm performing this technique on Metasploitable machine. So without permission, don't use it on someone else's system. See the result. Okay guys, let's see another technique. Technique number 4 is IP address decoy. This technique refers to generating or manually specifying the IP addresses of the decoys to evade IDS or firewalls. It appears to the target as well as the host or scanning the network. This technique makes it really difficult for the IDS or firewalls to determine which IP address is actually scanning the network and which IP addresses are a decoy. The purpose of a decoy scan is to confuse network defenders and make it more difficult for them to identify the true origin of the scan. Let's see in practical example. One side we perform IP address decoy technique, and the other side we analyzing traffic with help of Wireshark. We use this command. See, we have multiple IP. These decoy addresses are then included in the scan packets sent to the target, making it appear as though multiple hosts are scanning the target simultaneously. When performing a decoy scan with NAP, the user specifies one or more IP addresses to act as decoys using the -D option followed by a list of decoy IP addresses. These decoy addresses are then included in the scan packets sent to the target, making it appear as though multiple hosts are scanning the target simultaneously. Technique number 5 is spoofing the IP address. Spoofing the IP address is one of the hijacking techniques, where an attacker obtains a computer's IP address, alters the packet headers, and then sends the request packets to the target machine, pretending it to be a legitimate host. The packets also appear to be coming from a legitimate source, but actually are sent from the attacker's machine. Mostly firewalls filter packets based on the source IP address. The firewalls examine the source IP address and determine whether the packet is coming from a legitimate source or some other source. When the attackers send a connection request to the target host thus replies to the spoofed IP address. We will use hping3 to perform the IP address spoofing. Let's go to the Kali Linux. Open Terminal and Wireshark for analyze traffic. Let's set IP addresses. First of all, we will set our specific IP address. This is our target IP. And this one is our spoofed IP. Let's look at our packet capture tool. Here you can see source IP and destination IP. First, check our IP. Our IP is 10.0.2.15. So, it's clear that we didn't see our IP in Wireshark. Clear both and see another command. This is exact like our previous command, but here we increase time to live option. Let's stop the process and click on source IP. Here you can click on Internet Protocol. Here you can see Time to Live 128 option, as we set before. Let's increase another option, which is port number. We can add port number in spoofed address. Here we will set port 80. For capturing it, click one of source IP, then click Transmission Control Protocol. Here you can see a destination port number, which is 80. Clear everything, and see another command. In this command I will show you how to change random IP addresses continuously. Here we don't specify IP address, so our command will be ran source. Here below you can see port number. Let's focus on source addresses. Our IP address continuously change. Okay, let's move on to technique number 6, which is customizing packets. An attacker can create and send custom packets to scan the intended target beyond the firewalls or intrusion detection system. This can be done by several methods. Method number 1 is creating custom packets by using packet crafting tools. An attacker creates custom TCP packets to scan the target by evading the firewalls. Several packet crafting tools, such as Colosoft Packet Builder or NetScan Tools Pro, can be used to scan the target beyond the defense mechanism. The main aim of the packet crafting tool is to craft and send packet streams using different protocols at different transfer rates. Method number 2, creating custom packets by appending custom binary data. This method includes sending binary data 0s and 1s as payloads in the packets to the target machine, present behind the defense framework of the target. We can use Nmap to customize packets by appending custom binary data. It is important to understand that to perform a byte order conversion, the specified information should be based on the receiver's expectation. This is how you can use Nmap in this case. Method number 3 is creating custom packets by appending custom strings. Crafting packets is not limited to the binary data, but an attacker can send the regular strings as payloads in the packets for scanning beyond the firewall as well. The last method we have is creating custom packets by appending random data. An attacker can append several random chunks of data to most packets, sent without using any protocol-specific payloads. Nmap provides an option for appending random data to the packet by using --data-length. Technique number 7 is randomizing the order of host. The attacker scans the number of hosts in the target network in a random order to scan the intended target that is secured behind the firewall. Our favorite tool Nmap provides us an option of randomizing hosts as well. This methodology instructs the Nmap to shuffle each group of 16,384 hosts before scanning with slow timing options, thus making the scan less notable to the network monitoring systems and firewalls. Technique number 8. Sending the bad checksums. To bypass firewall rules, the attacker transmits packets with invalid TCP or UDP checksums to the target. Checksums are used to check the integrity of the packet. Here we will use this command with Nmap. Technique number 9. Proxy servers. A proxy server is an application that can serve as an intermediary for connecting with other computers. A proxy server is used to fulfill the various purposes of firewall and IDS evasion, masquerading the original source, remotely accessing intranets. Proxy chaining is also an option that helps an attacker to maintain their internet anonymity. Some examples of proxy tools are Proxy Switcher, CyberGhost VPN, etc. The last technique is anonymizers. An anonymizer is an intermediate server that is placed between an attacker and the website to access the website on behalf of an attacker to make the surfing and other activities untraceable. Most anonymizers usually anonymize the web, file transfer protocols, and similar other services. Nmap offers various techniques to bypass the firewall and IDS, and these techniques only work if IDS or firewalls are misconfigured. So in a network that has IDS and firewalls properly configured, most of these techniques may not work. Every situation is different, so you need to decide which one will work for you. So, that's for it. I hope you enjoy the video. See you in the next lecture.